Okay, talking about area of a regular polygon, this is our formula for finding just that, where the little a is the apothem and the capital P is the perimeter of the shape. And this is only for regular polygons. Okay, we are going to look at number 8 to begin with. And it tells us that the radius of a square is 5 square root of 2. Find the apothem, perimeter, and area of the square. Okay, remember the radius goes from the center of the shape to a vertex. So this right here is the radius, and it tells us that that is 5 square root of 2. And then the apothem goes from the center of the shape to a middle of a side, and it's always perpendicular to the side. So this is the A. That's the apothem. Okay, so let's see what we can do here. Okay, first of all, I know that if I want to find my central angles, and I'm going to go ahead and I'm just going to draw them in for you. And draw these 2 diagonals in, and it creates our 4 central angles. So since a square has 4 sides, it has 4 central angles. And if you want to know what each of those central angles has a measure of, you take 360 and divide by however many central angles it has, or how many sides it has. So I take 360 and I divide by 4, and that makes every central angle 90 degrees. So this central angle is 90 degrees. This central angle is 90 degrees. This central angle over here is 90, and this central angle over here is 90. Well, what the apothem does is it splits that 90 in half, making this a 45-degree angle, and this other piece over here a 45-degree angle. So whatever the central angle is, the apothem will always cut it in half when you go to work with this triangle over here, made by the apothem and the radius. So if this is 45 and this is 45, if this is 45 and this is 90, then this is 45. So we are working with a 45, 45, 90 triangle. Okay, here I go with my labels. Across from the 45 is X. Across from the other 45 is X. So I'm just going to draw over top of that A for a little bit and just remember that it's the apothem. And across from the 90 is X square root of 2. Now if we already have a number there, remember to put an equals between it and your X square root of 2. Do you know what X is without me actually solving this? X is 5. If these two are going to look exactly alike, this has to be a 5. Now if I was to mathematically solve it, to get X by itself, I have to get rid of square root of 2, and you undo multiplication with division. So I would divide both sides by square root of 2. Anything divided by itself is 1. Shoop. Anything divided by itself is 1. Shoop. And you can see that X is 5. Okay, so from here to here is 5, and from here to here is 5, because those are both X's. Okay, so let's start with the chart down here. The radius, we were given that. That was the 5 square root of 2. The apothem, I just found that, and we found that to be 5. Okay, now I can do perimeter. I know that since the apothem is in the middle of a side, that if it's 5 from here to here, and it's 5 from here to here, how long is each side of the square? 10. So if every side of the square is 10, then what's the perimeter? 40. 10 plus 10 plus 10 plus 10. Okay, I know because this is a square, I can find the area doing side squared or length times width or base times height, but I want to practice our new formula that we can use for all regular polygons. So it tells you to take 1/2 times the apothem, which we found to be 5, times the perimeter, which we found to be 40. And if I work that out without a calculator, I could take half of 40, which is 20, and 20 times 5, which is 100. For most of you that have a calculator, I imagine that you would go 5 times 40, divide by 2. And that's our area, and this was in centimeters, so I'm going to give it centimeters squared. Okay, let's go to number 11. Number 11 tells us the apothem of a regular hexagon is 5 square root of 3, Okay, so this is our apothem. It goes from the center of the shape to the middle of a side, and it says that that apothem is 5 square root of 3. And then it says find the radius, perimeter, and area. Okay, so let's just go ahead and write down that the apothem is 5 square root of 3. Get one thing out of the way. Okay, this guy right here is the radius, because it goes from the center of the shape to a vertex. So I need to know what all my central angles are. So I could draw them all in. I'm just going to do it just a little bit here. Kind of light. So all my central angles. So here, 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 and this one. So since this hexagon has 6 sides, then I'm going to divide by 6. That's how many central angles there are, because that's how many sides there are. And I get 60. That means every single central angle is 60 degrees. Well, what the apothem does is it takes the central angle and it chops it in half when you make this triangle. So this is a 30-degree angle right here. And if that's 30 and that's 90, then this one right here is 60. Okay, so now we're going to do our labels with the 30, 60, 90. Across from the 30 is x, and that would just be from here to here. Across from the 60 is x square root of 3. Now remember, if there's a number there, put an equals between it and the label. And across from the 90 is 2x. Let's see if we know what x is. I don't, but what if I solve this equation? Do you know what I would get? 5. So technically, to solve it mathematically, if I wanted to undo multiplication, I'm going to divide both sides by square root of 3. Anything divided by itself is 1. Anything divided by itself is 1. And you can see that x is 5. So if x is 5, then from here to here is 5, which means from here to here is 5, which means how long is every side of the hexagon? 10. 10, 10, 10, 10, 10, 10. Okay, and then this radius says take 2 times x. Well, we just found x to be 5, so 2 times 5 is 10. So the radius happens to be the same as the length of a side of the shape, but it doesn't always work out that way. So the radius is 10, so let's put that in our chart. The perimeter would be 10 plus 10 plus 10 plus 10 plus 10 plus 10, which would be 60. And then let's practice our new formula, 1/2 AP. So I know the apothem is 5 square root of 3, and I know the perimeter is 60. Okay, without a calculator, I'm going to show you how I would do it. I would take half of 60, because I can't take half of 5 and get something nice. So half of 60 is 30. 30 times 5 is 150, and I get 150 square root of 3. If I were to use my calculator, without putting the square root of 3 in there, I could take 5 times 60, divide by 2, and then tack on the square root of 3. If I wanted to know what it was as a decimal, I could put 150 square root of 3 in the calculator, and you get about 259.8. So I'm going to say approximately 259.8, just to throw that decimal in there. And this was in meters, and its area, so in meters squared. Okay, are we loving this? All right, let's go to the next page, page 17. This is review from what we have already done, but I'm just going to review it real quick. So first of all, do you know what represents the distance around a circle? Circumference. So circumference is the distance around the circle. Perimeter is the distance around every other shape out there. And when we talk about a circle, the distance around it is called circumference. Okay, so if I want to find circumference, I can either use the formula pi d, which happens to be my favorite, or 2 pi r. But it doesn't matter which one you use. And then I'm not going to fill these in because I think you know. But C is circumference, D is diameter, R is radius. Okay, and then I'm just going to write this down. Area of a circle, that's the space within inside. It uses the formula pi r squared, where A is area and R is radius. Okay, let's just do a couple review problems. So here I'm supposed to find area and circumference if I know that the radius is 7. So if the area formula is pi r squared, and I know the radius is 7, I'm going to put a 7 right there in the r. So pi times 7 squared. I'm going to take the 7 and square it, which is 49, so that's 49 pi. And if you notice back here, the directions do say to leave in terms of pi. So I'm going to just leave it like that. And if I gave it a unit, it would be centimeters squared. Okay, circumference. I can either use 2 pi r or I can use pi d. I'm going to use pi d just because I like it. So if the radius is 7, what would the diameter be? 14. So it would be pi times 14, which is simply 14 pi. And that would be centimeters. We're going to be doing a little bit more with circles in the next few days. Nothing too major because we've already had our big circle unit. But this is just a little review on that. Okay, this next question is basically the same except they give you the diameter. So I'm just going to skip it. Okay, we're going to do 2 more and we're going to call it good for this video. Okay, example 3. A bicycle wheel travels 85 inches in 1 revolution. What's the approximate diameter of the tire? Okay, so the wheel travels 85 inches in 1 revolution. That means in 1 full circle, it travels 85 inches. Well, what word talks about what something travels in a full circle? The distance around a full circle? Circumference. So I know the circumference is 85 because that's what it traveled in 1 revolution. That's the distance the wheel traveled in 1 full circle. So that's your circumference. Okay, question is, what is the approximate diameter? So I'm going to write down my formula for circumference. And once again, I can either use 2 pi r or pi d. It doesn't matter. Since the circumference is 85, I'm going to put 85 right here into the C. And I'm going to recopy. Since it asks for the diameter, I need to get d by itself. So how can I get rid of pi? Divide. So I'm going to divide both sides by pi. Pi divided by pi is 1. Shoop. And this is my answer. I'm just going to go ahead and do a decimal approximation. So 85 divided by 5. If I round to the tenths, I get the diameter to be about 27.1. And this is in inches. Okay, one more. Example 4. The area of a circle is approximately 78.5 square units. Find the diameter. Okay, I'm looking for the diameter and I'm given the area of the circle. Okay, so I'm going to write down my formula for area of a circle. We only have one choice, pi r squared. I know the area is 78.5, so I'm going to put 78.5 right there into the A. I'm going to recopy the pi r squared. And I'm going to solve this equation for r. It's the only variable I have. So to get rid of pi, I'm going to do what I did in the last problem. I'm going to divide both sides by pi. Shoop. And I'm actually going to put this in the calculator right now. So 78.5 divided by pi. And if I round to the tenths, it would be 25. So I'm just going to go ahead and do that. It would be 25. So I get r squared is approximately 25. And then how can I get rid of the squared? Square root. So I square root both sides. I get the radius to be 5. But the question says find the diameter. So if the radius is 5, what's the diameter? 10. And I keep putting the squiggles because it's approximately 10 because I had a round right here and it was approximately 25, so it's approximately 5, so it's approximately 10. And then we didn't actually have a unit here, like centimeters, feet, or anything. So the diameter is approximately 10 units. And that's all for today. Thank you. Smiley face.